Good morning, everyone, and welcome to this session of the SPA workshop. I will be your chair today, helped by Simone as a technical assistant. Good morning, everyone, and we can get started with the first presentation in the program, which I don't seem to find. Okay. The first presentation is by Spartaco Paris, Francesco Tajani, Giuseppe Cirullo, and Giulia Famiglietti. And the floor is yours, and you have about 15 minutes so that we can have some room for discussion and questions. So, can you please
Thank you.
your
Thank
mic?
you.
Hi, Giulia. Can you
Hi.
also share your screen?
Yes, of course. Okay. Can you see my screen?
Yes, we can. Can you switch it to presentation mode?
Okay, switch it.
Maybe you could just share the whole screen because we see the PowerPoint standard interface. So rather than sharing the application, try and share the full screen.
Oh, sorry. So now can you see the presentation?
No, still with the left-hand side list of all the slides and in the classical interface. Try and stop sharing.
Okay.
You're still sharing.
Yes. Okay.
Okay. Try and share the full screen and not the application.
Okay. Now can you see the presentation?
Yes, that's perfect. Thank you.
Okay.
The
Sorry.
floor is
Thank you.
yours.
Okay. So good morning, you all. Let me introduce myself. I am Giulia Famiglietti, a PhD candidate of Sapienza University of Rome. And today I'll share a study conducted in collaboration with Spartaco Paris, full professor at Sapienza University, engineer Francesco Tajani, associate professor, and engineer Giuseppe Cirullo, also a PhD candidate in our department, who is here today to present with me the second part of our research project, titled A Methodological Approach for the Parametric Assessment of Residential Construction Costs. First of all, the study is intended to provide an updated reference on the construction cost of new residential building interventions in the territorial context of Lazio region, Italy. Through the analysis of representative building works and their systematization in synoptic sheets, the study was to return a transparent, clear, and traceable comparative picture of unit construction costs. The second objective concerns the determination of the percentage contribution of the different intervention categories, such as foundations, fixtures, systems, to the total construction cost. In this way, it will be possible to have an idea of the weight of the different construction subdivisions, making it possible to act according to the project budget on the different intervention areas, depending on specific targets of the client and architect. The third objective intend to solve a flow in the estimation of parametric construction costs. And indeed, the literature lacks a methodology for determining the construction cost value, referring to a unit of consistency. It also includes accessory surfaces by means of appropriate homogenization coefficients with respect to the gross built area. Here you can see a conceptual workflow of the methodology phases. So starting from an analytical study of the final execution level project tables and estimated metric calculation of the endorsed case studies. For each case studies was carried out the disaggregation of the working clusters that contribute to defining the project, and also were defined the intervention categories. Then were made measurements and validations of the quantities for each category according to the working cluster to which it belongs. And those led us to the determination of the overall construction cost for each working cluster and in parallel for each intervention category. So for each working cluster was determined the unit cost and the percentage contribution of the accessory working cluster to the gross built-up area. The latter contributes to the definition of a new parameter defined as homogeneous built surface. For each intervention category was estimated percentage contribution of each individual category concerning the total construction cost and as well as the total cost of the entire building intervention. And finally, was made a calculation of the parametric construction cost per gross built-up area and the parametric construction cost per homogeneous built surface, with the preparation of an analytical project sheet for each case study. So to obtain an analytical tool was constructed a reference matrix from a dual classification of the items that contribute to defining the total construction cost. The first classification, working cluster, considers the building components that, together with the gross built-up area reference components, constitute the homogeneous built surface. The second classification, intervention category, considers the disaggregation of intervention into technologically homogeneous building components. Here you can see the matrix model template. And so as you can see in the identification of the intervention categories, further classification by macro categories was taken into account. So such as construction, structures, electrical system, other systems. And once the matrix had been constructed, the data were placed by associating each item of the estimated metric calculation with the corresponding reference category, according to the working cluster to which it belongs. So for each item were reported quantity, unit cost, and total cost values. So at this point, the percentage contribution of each working cluster contributes to the definition of the new parameter homogeneous built surface. So the need to define this parameter arises from the need to consider certain accessory surfaces such as stairs, lift, terraces, gardens, which although not directly included in the gross built-up area, have a significant impact on the overall construction cost of the building. In order to determine this new parameter, was analyzed a sample of 5 newly built residential properties realized between 2023 and 2024, with an exception of one case study for which a cost update was performed. The analysis was conducted on buildings located in the Italian territory, and among the compendiums identified, 3 are located within the urban transformation area of the city of Rome. One is located in the province of Viterbo, Lazio, and the 5th case is located in the province of Naples, Campania. Were considered the tower and inline buildings of approximately 5 stories, characterized by the presence of a basement floor used as a garage or carpet, for a total of approximately 40-50 dwellings, and 2 buildings of 4-5 stories above ground level, for a total of approximately 20 dwellings of variable 2, 3, 4 room size. So now I'll give the floor to my colleague. Thank you all.
Okay, good morning. Share my screen. Can you see my screen? No.
No.
Yes, we can see your screen. Can you go full screen mode, please?
Okay. Can you hear me? Can you see? Yeah.
So we
No.
can only see the standard interface. You should share the full screen and not the application.
Giulia, forse interrompere tu. Ok. Ok. Ok.
No, we see okay, now it's working. Yeah.
Okay, delay. Yeah. Good morning, everyone. Thank you, Julia, for introduction. In the next slide, we explain the methodology development process and present some of the main results. On the left, you can see an example of the output we produced. And for each property, we created a detailed table that show the total construction cost, the unit cost, and the percentage contribution of each working cluster to the overall cost. After analyzing each building, it was possible to obtain average results, both for the asset located all in a room and for the entire portfolio, so asset in Viterbo and Quarto. In this way, we could understand on average how much each working cluster impacted to the total construction cost. In detail, here we can see two different comparisons. When we analyze the total cost incidence of the working cluster in relation to the overall economic size of each intervention in the bottom graph, we noticed a more uniform trend compared to the analysis based on the unit parameter in the top graph. These results indicate that through each case study is characterized by a specific design shows that significantly influence the unit cost of the working class. In total calculation, the distribution of the cost tend to rebalance. After analyzing the working class, we moved on the next step. As you can see on the left, the table on the left, for each case study, we prepared an interactive project sheet to have a complete characterization of the construction costs of the intervention and to quickly identify the contribution of the cost item or category to the overall project. On the right, once again, from the average data shown table, it can be deduced that the category of intervention that have the most significant impact on the overall construction cost are lateral concrete works, which represent the preponderant share with an average incidence of around 90%. Followed by intervention relating to water and heating system, which represent around 13% of the overall cost. In order to consider the factor that may influence the final construction cost, we defined two correction factors, the construction site accessibility factor and the demolition factor. For the construction site accessibility, we define different percentage adjustment depending on the location. We can observe a gradient of accessibility from the historical center to the peripheral area. Condition move from easier to progressively more critical, where logistical complexity became more challenging. In addition, the other correction factor refers to demolition and reconstruction initiative. In this case, it's possible to increase all results by applying a specific percentage to account for the extra cost related to demolition activities. Finally, to validate the output obtained, we carry out the comparison with the day price list. By comparing the percentage incidence on the total construction costs of the above ground volume and the basement, we observe that for the above ground part, the value range between 89% and 92%. Similarly, for the garage component, the value range between 8% and 11%. Both show only a marginal variability of about plus minus 3%, which indicated a high level of design homogeneity. For more, when we look in detail at each component, as you can see from the chart, we notice that apart from one outlier, there is a strong coherence between the value we obtain from the case study and the reference value from the price list. This really confirms that your results are consistent and well aligned with the established benchmark. In conclusion, the results obtained for the case study located in urban context Rome show value ranging from around 2,400 to about 2,800 euros per meter, with an average of approximately 2,600 euros per square meter. Considering all forecast study, so excluding the outlier, the average unit cost for gross building area is approximately 2,300 euros per square meter. Then, if we analyze the unit cost calculated using the homogeneous building surface, we see that for the Roman building, the value range from around 1,800 and to about 2,100 euro per square meter, with an average of around 1,900 euros for square meter. Overall, the average homogeneous build surface unit cost for the forecast study, so total, is approximately 1,600 euros per square meter. In addition, depending on the different characteristic of the building, it's possible to apply the correction factor we saw earlier. So, thanks to determination of a unit construction cost, both for the gross building area and for the homogeneous building surface, and above all, thanks to a detailed breakdown of the cost incidence for each working class and each intervention category, the proposed methodology can serve as a reference for the operator involved, acting as a practical guide for estimating, monitoring, and updating the construction cost in the residential sector. Thank you for attention.
Thank you. Thank you so much also for sticking perfectly to the allotted time. And if anybody has questions from the virtual room, you can use your raise hand utility. And I would like to ask to what extent you think that this methodology is scalable. I mean, it can be replicated in perhaps in other Italian cities and beyond. I mean, are there any limitations that you can identify when thinking of applying the same methodology to context other than Rome?
Okay, maybe I think that this methodology lacks in a more wide sample, because now we have analyzed only 5 examples located in Rome, and it's really difficult to have the informations because all the construction societies doesn't want to give us the data. Maybe this is the more challenging thing. Because if you want to replace this study in another, also in another country, if you want, I think that you need a more wide sample first, and then I think that the strong point of this methodology is that is the matrix model, because with this model you can analyze all the estimated computation. So you need to start from the estimated computation. With this, you have to divide in categories and working cluster that is the same in, I think, or quite the same in all the project, maybe the main one. And so in this way, following the calculation of the homogeneous built surface that belongs in part to the gross built-up area, you can have satisfying results, I think.
Thank
I don't
you.
know if I have.
Thank you so much. Now we can switch to The next presentation, which is by Paolo Arabaglia, Marco Gona, Teresa Tuparo, Giovanni Giangone, and Franco Petenati.
No, I think
Oh,
this can go on.
nobody is online from this presentation, so Martina Marras, can you please switch your camera on?
Yes, of course. Good morning.
Welcome, Martina. She delivers a talk about strategic environmental assessment and the local framework approach, integrating the 2030 agenda into spatial planning. Martina, sorry, 50 minutes for you also.
Thank you. Okay, can you see the presentation?
Yes, and in full screen mode.
Okay. Good morning. My name is Martina Marras. I am a PhD student at the University of Cagliari, and I'm going to present my paper entitled Strategic Environmental Assessment and the Logical Framework Approach, Integrating the 2030 Agenda into Spatial Planning. Non va avanti. Okay. The presentation is organized into 3 sections. First, I introduce the context, the objective of the research, and the key concept of the study, the strategic environmental assessment, commonly referred to as ACA, the 2030 agenda, and the logical framework approach, referred to as LFA. Second, I detail the methodology and illustrate its application in the case study. And third, I summarize the main findings, reflect on the broader implication and the future development of the study. ACA is increasingly recognized in both the literature and practice as a strategic instrument for embedding the sustainable development paradigm into decision-making processes and for supporting the effective pursuit of the sustainable development goals. So in this context, the study proposes a methodological model grounded in the LFA for integrating the sustainable development paradigm into spatial planning. Through the case study of the ACA carried out for the Tepilora Regional Natural Park Plan in Sardinia, Italy, the methodology was conceptualized and tested to demonstrate its effectiveness in a real-world planning context. ACA has its origins in project-level environmental impact assessment as an instrument for environmental protection, primarily based on the assessment of the environmental effects of policies, plans, and programs. But over time, there was a growing recognition of the need for a broader and more comprehensive assessment tool, and this led to the development of a new approach to SAA, complementary to the first known as the strategy-based approach, which differs from the other model by acting as a proactive instrument designed to support the decision-making processes rather than the merely assessing environmental impact. So the European ACA directive formalized and consolidated this evolution by setting clear objectives: protecting the environment through systematic impact assessment, integrating environmental consideration into decision-making, and promoting sustainable development. So this latter concept, originally introduced in the Brundtland report, takes on a new global dimension in the 2030 agenda. For the first time, sustainable development is framed within a broader and more structured paradigm, one capable of addressing complex and at times conflicting emerging goals while advancing a shared model of economic, social, and environmental development. So this paradigm shift required the identification and adoption of innovative tools and methodologies capable of effectively integrating the SDGs into governance processes. And in this context, the ACA emerges as a key instrument, but this represents not only a theoretical methodological challenge, but in countries such as Italy, also a legal requirement. Here, the sustainability paradigm is articulated across multiple governance levels, at a global level through the 2030 agenda, at the national level through the National Strategy for Sustainable Development, and at the regional level through the various regional strategy for sustainable development. And collectively, the law affirms that these frameworks provide the reference context for environmental assessment. So to effectively integrate the sustainable development paradigm into spatial planning through ACA, this study adopts the LFA. This is a project planning, management, and evaluation tool that structures planning or project challenges within a clear framework known as the logical framework matrix, refer us to LFM. The latter, primarily defined by goals, objective, activities, also can include performance indicators and means of verification. It provides a concise visual representation of the intervention logic and contributes to, among other things, the strategic coherence and stakeholder engagement. In this specific case, so the question is, why choose LFA to SEA? To define the strategic dimension of the plan through a continuous process of evaluation and planning, to shift from a reactive to a proactive assessment, to enhance the internal logic and operationalization of plans, and of course, to effectively integrate the sustainable development paradigm into spatial planning. So the research was conducted through a learning by doing process, which made it possible to elaborate the theoretical framework while applying it in practice within a dynamic and flexible cycle of learning and adaptation. The case study is the Regional Natural Park, a protected area located in Sardinia, an Italian island in the Western Mediterranean, that approved its regional strategy for sustainable development, referred as to RSSD, in 2021. As shown in the map and in the section, Tepilora Park spans roughly 8,000 hectares, extending from the Iceland inland mountains across an agricultural plain to the coast following the course of a major regional river. The area encompasses a landscape of high values, ecological complexity, and rich biodiversity. And also the river's mouth is designated as a Ramsar wetland, and part of the park lies within a UNESCO Biosphere Reserve. So in this context, the main planning challenges include the protection and enhancement of natural resources and local peculiarities, the well-being of local communities, and of course, the promotion of sustainable development. So this study proposes integrating the sustainable development paradigm expressed at a local scale by the RSSD of Sardinia with the plan's strategic dimension as articulated through its objective and action, structured with a four-level logical framework matrix, and keeping in mind the definition of integration as a generative process that unifies distinct elements to create outcomes that goes beyond the sum of their parts. So the LFM, as we can see in this slide, is organized according to a coherence hierarchical logical. The four levels consist of the plan action, which are aimed at achieving the specific objective. These objectives align with those of the higher level plans and programs in force within the planning context, contribute to pursue the environmental sustainability objectives, reflecting the specific need of the planning area as identified through the environmental analysis of the environmental components. In particular, the first level of the LFM comprises environmental sustainability objects. These are derived from the integration of the sustainability object identified through the environmental analysis and those of the RSSD considered relevant to spatial planning and the specific context. For example, the objective safeguard geological heritage, including with reference to landslide risk, is linked to the objective reduce exposure to landslide and flood risk, resulting in the integrated objective safeguard geological heritage while reducing population exposure to landslide and flood risk. The second level of the LFM consists of external coherence objectives. They are derived from an analysis of the high-level and parallel programming and planning instrument in force within the context and are not integrated with the RSSD because, unlike the other elements that directly shape the plan strategy orientation, they serve as an external reference framework to ensure the plan does not diverge from or conflict with the existing governance system. The third level of the LFM consists of the specific objective of the plan. They result from the integration of three types of objectives. The governance objectives reflecting the political and administrative priorities, planning objective defined by the planners, and RSSD specific objective. Distinguish among these categories is essential because each can reflect different priorities. For example, governance objective may privilege economic growth at the expense of sustainable development. But in this case, however, governance and planning objectives coincide, and the planners have adopted a methodology oriented toward the sustainable and integrated protection and management of resources, firmly rooted in contextual analysis. As a result, the specific objective of the TP-LoRa Park Plan stem from two main sources: the context-specific objective and the RSS-specific objective, considered relevant to spatial planning and the specific planning context, both tailored to the plan's context. Here we have an example that you can find also in the paper, and the fourth level of the LFA consists of the plan action. This study identified three sources for this action. Context-specific action, which, like the corresponding objective, reflect governance and planning priorities, and in this case are firmly rooted in the environmental analysis, with a strong orientation toward sustainability. Local planning action, defined at the national level to promote the sustainable development paradigm at local level, and RSSD actions, which were considered relevant to the themes addressed in the TP-LoRa Park Plan. Since all of these actions are already oriented towards sustainability, further integration for that purpose is not essential, but however, merging and reformulating them is important to avoid the redundancy that could undermine the effectiveness of the LFA. Here we have an example that shows three actions for each sources and how are sustainable oriented. Finally, this slide presents an excerpt from the LFM of the TP-LoRa Park Plan, showing only 3 of 10 environmental components, each with just a single objective and one related action. However, in fact, the complete LFM is more complex, and as we can see in the paper in the slide, is the result of 100 interactions among elements. So the reflection introduces some aspects to be aware of in relation to the developed method. First of all, the potential complexity of the LFAM, redundancy among strategic elements, oversimplification of the plan's multidimensional nature, excessive abstraction in representing territorial transformation, and the difficulty of identifying appropriate indicators, especially when objectives in the field of spatial planning are often qualitative in nature. However, the research also generates several significant outcomes. The shift from reactive to proactive assessment, the continuous integration of evaluation and planning, the strengthened internal coherence and operationalization of the plan, and first of all, the substantive integration of the sustainable development paradigm into spatial planning, achieving through ACA. So the study also carried broader implications. In fact, the LFA enhances the transparency and verifiability of the planning and evaluation process, allowing for modification and integration by also the stakeholders involved. Moreover, the LFA combines analytical rigor with operational flexibility, and this feature together with the aspects said before, make the methodology adaptable and replicable across different contexts and scale. In fact, together with the research team, we also tested the methodology on the municipal urban plan of Cagliari. In conclusion, this methodology is well developed, but still holds the potential for further refinement, particularly through experimental application. This slide presents the research program within which the study was conducted, and thank you very much for your attention.
Thank you, Martina. Are there any questions from the room or from the virtual room? No? Okay. So you touched upon a few issues in one of your last slides, and I was wondering if you could tell us more about the problems that can be encountered when trying to apply this methodology, which looks super complex because it tries to bridge a number of different tools under one kind of super matrix and try to make all of the tools consistent. And I wonder whether this is always possible or how to handle any inconsistencies which you might find among the different tools that you are trying to integrate.
Thank you, Prof. Lai, for your questions. Yes, the methodology is really complex. I try to simplify it to make it more communicated. It's really complex, and there are a lot of problems that we find through the two project pilots. One is Tepilora and the other is Cagliari. And for example, the complexity. In Cagliari, we done also the preliminary plan, and there was a lot of objectives and action, also because was a preliminary plan. So we needed a more complex matrix in the preliminary phase. Instead, in Tepilora, we did a more a matrix that have an important in the executive part. So the matrix became more simplex, but simplex. More effective. So another problems here is the, of course, the for example, the territorialization of the action of plan. They are connected also with the financing, the resources to finance the plan. So it's really important to understand the action, how they can become concrete in reality, and excessive abstraction, and also the problem of the indicators. A bigger problem of the strategic environmental assessment is the monitoring in the implementation phase. So find good indicators in that phase, and find the resources to go beyond with the monitoring and adaptation of the plan is really important, and this is one of the issues.
Thank you. I don't seem to get an answer on inconsistencies. Did you find any?
Sorry, can you repeat, please?
It seems to me that you didn't touch the inconsistency bit of the question. Did you find any inconsistencies when applying the methodology between two or more plans? And if you did, how they were handled?
What do you mean with inconsistency?
For instance, that could be, it's not your case, but I'm thinking of, developing renewable energy plants which might clash with protecting the landscape objectives, something like that. It's not your case, so I'm just asking whether
Okay.
we can address inconsistencies within this tool.
No, maybe not, because integrating, because in this study, in this methodology, we try to include the paradigm, the sustainable paradigm, and also the technical and governance and political orientation. So in the context like Europe, this is more easier because we have a strong attention with environmental themes, and in other contexts this could be more complicated because maybe the priorities of governance and the administrative priorities are really different from the environmental protection. So maybe if the inconsistency could exist in some particular context in which, for example, the priorities like the economic growth are more important respect of the, for example, environmental protection of enhancement. I hope I answered to the question.
Thank you. Thank you so
Thank
much,
you.
Martina, for the comprehensive reply. And now we can switch to the fourth presentation. I saw somebody online, Anna Pelosi, together with Gianmarco Accetto, Angelo Luigi Aprile, and Giovanni Battista Chirico, about evaluating the performance of the global weather data set for sustainable weather management in agriculture. Welcome, Anna. The floor is yours. Can you please share your screen?
Yes.
Full screen mode, please. Thank you. Perfect. 15 minutes.
Thank you. Good morning. I am Anna Pedosi, an assistant professor from University of Salerno. Today I'm going to talk about the evaluation of the performance of the global weather dataset AG-ERA5, used for sustainable water management in agriculture. Of course, the reference today, the focus will be on just on reference evapotranspiration. And just a quick introduction about the definition, just to share a common framework and common definition on that. According to the Food and Agriculture Organization, the reference evapotranspiration is the rate of water loss from an hypothetical reference surface due to evaporation from soil and leaves and transpiration from plants. And typically, this hypothetical reference surface is a grass field, well watered and with optimal agronomic condition. So it serves this definition as a standard for comparing evaporation rates across different locations and times. And this definition is crucial for irrigation management and water resource planning. Indeed, the computation of reference evapotranspiration helps to, if multiplied with some crop coefficients, helps to assess the effective crop evapotranspiration. In particular, if the reference evapotranspiration depends only on meteorological variables such as wind speed, temperature, or solar radiation, relative humidity, the crop evapotranspiration depends also on crop parameters, depend on the crop types and crop stage development. However, if meteorological variables can be assumed by means of observation in certain point of the ground-based meteorological network or from numerical weather prediction outputs, the crop parameters may be integrated in the framework by using remote sensing multispectral images. However, the crop evapotranspiration is an input data for in soil water balance modeling for estimating irrigation. In fact, the difference between crop evapotranspiration and net rainfall by neglecting all the other processes, complex processes related to the percolation of the end of the water storage modification, this differences is the irrigation. So it is possible from the reference evapotranspiration somehow compute the irrigation at the end. So the reference evapotranspiration represents a key variable in the process and is the key variable in the current study. Why is important to estimate irrigation needs, irrigation volumes? Because today agriculture accounts for the 70% of total water use. So the agricultural water management assumes a significant role within the current European policies, and both for climate change adaptation and sustainable development. So a rational and more rational use of water in agriculture may for sure help in meeting all the sustainable development goals indicated in the slide, number 2, 6, 12, 13. But to meet an efficient agricultural water management activity, it is necessary to assess the actual irrigation water needs and water volumes across the country, and in order to identify specific actions in specific area in single district. Moreover, this necessity to quantify the irrigation volumes, the irrigation water uses, is also a condition set up by the Water Framework Directive and by the ministerial decree in Italy of the Ministry of Agriculture, Food and Forestry Policies. And according to these frameworks, directives, it is necessary to update constantly the knowledge about irrigation needs in the Italian agricultural context, and it is necessary to identify some tools and methodology for quantify the irrigation volumes. Of course, direct measurements of irrigation volumes are not available, are very expensive if we would like to start a field campaign, but in the all Italian territory is very difficult all over the Europe. So indirect estimates of irrigation volumes are needed. And this methodology, by starting from the reference evapotranspiration through a crop evapotranspiration assessment and then soil water balance models, may help in the scope, for the scope. Of course, this study is an intermediate result with the objective to assess the daily reference evapotranspiration, and in particular we have used the Penman-Montate formulation, which is a kind of standard also proposed by the Food and Agriculture Organization. And in particular, we have the dependence on some weather variables such as said, solar radiation, wind speed, relative humidity, and temperature, of course. So the idea is evaluate the performance of the use of latest reanalysis datasets such as AG ERA5 and ERA5 Land as proxy of ground-based weather observations. For assessment of the daily reference evapotranspiration. The study area was the Campania region located in southern Italy. Here we have available a ground-based weather monitoring network composed of 18 weather stations. And of course, when we use the ground-based weather station in a certain point, we have the weather truth. However, as soon as we would like to perform a special analysis, so we need to interpolate the data. So the ground-based weather observation are the weather truth only in the point of measurement. Elsewhere, in unmonitored sites and on a regular grid, for instance, the special interpolation commits some errors. So maybe using special interpolated ground-based data may not be the best way to estimate weather across a region. And this is the point of the study. Since climate reanalysis are improving their performance due to the improved performance in time of numerical weather prediction models, maybe reanalysis can constitute a useful proxy for ground weather observation. Moreover, those data are freely available, easy accessible, are very easy to integrate in a decision system, in web decision systems. So, and there is another important point. Reanalysis database have a time series that span very for a long time back in time, and this is a consistent database, very long, and moreover, this database can combine the laws of physics with the observation, giving the best estimate of the atmosphere that we can have for the past. An example is the ERA5 database, reanalysis database, that is a product of the European Center of Medium Weather Forecast. And from that database, we analyze two derived products that are AG ERA5 and ERA5 land. Those databases have a higher spatial resolution than the global reanalysis ERA5, that have a spatial resolution of about 30 kilometers, while the reanalysis database ERA5 land has a spatial resolution of about 9 kilometers. And this is a replayed component, land component of the ERA5 database. Moreover, we also have the AG ERA5, that is a specifically tailored database for agricultural application, and is a product of ERA5 too. And the difference between the ERA5 land and AG ERA5 is that AG ERA5 gives daily data that are the main input interest in computing agricultural parameters. Moreover, the AG ERA5 cover all over the globe, while ERA5 land just covers land. And I will show very briefly the results of this comparison by showing some statistic for evaluating performance, in particular the percent bias and the percent root mean square error, that I think you know very well. So I will go very quick on this slide. And results show that, so in these graphs, I'm showing the performances in terms of percent bias and percent root mean square error for all the weather variables analyzed, and for the three database in input: the interpolated ground-based data, the ERA5 land data, and AG ERA5. Of course, the benchmark for comparison are the ground-based observation at the single points of measurement of the region. So the box plot refers to the spatial variability of the statistics over the region. The mean is these circle marks. As we can see, the temperature is the best predicted variable. In particular, the daily maximum air temperature outperforms the daily minimum air temperature. So an average regional percent root mean square error is equal about 16%, and is very similar for all the three analyzed database for weather inputs. According to air relative humidity, wind speed, and solar radiation, we have that the daily mean wind speed is the worst variable. We have a lot of errors in estimating this specific variable. However, as we can see in this case, on average, the AG ERA5 and ERA5 land outperform the interpolated ground-based weather data. For what concern daily mean air relative humidity and the solar radiation, we have a very similar, especially for daily solar radiation, a very similar behavior for all the three analyzed weather database. We have better performance for the interpolated ground-based data for what concern air relative humidity. But for what concern at the end reference evapotranspiration, we can see that the three databases show a similar performance. This is a great result, I think, because the use of this type of data, gridded data, like reanalysis, instead of ground-based weather interpolation, puts a lot of benefits, because those data are freely accessible. Those data are very useful in the communication with other kind of data. So I think that these results that show that in terms of errors, AG ERA5 and ERA5 land are similar to the interpolated ground-based weather data is very, very, very important. So at the end, this is the main final remarks, that the results that I show support the idea that gridded reanalysis is a good proxy for weather observation. Of course, we have applied a bias correction technique, very simple, but of course we need to apply a local bias correction technique to use this kind of data. However, it's very simple, and we just need some few years of data, measured data, to perform this correction. Then we can say that AG ERA5 output slightly outperforms the ERA5 land data, especially for what concern air temperature and solar radiation. And at the end, we can say that AG ERA5 showed superior performance that ERA5 land for assessing reference evapotranspiration, slightly superior performance. This work serves for future development, of course, because integrating these estimations with satellite multispectral image for assessing crop parameters and then irrigation needs, it is useful to support sustainable agriculture management, as I said, to plan investment and action, and at the end to identify maybe crucial areas for preventing water scarcity over a region. So thank you for your attention. I'm wait for your question.
Thank you so much, Anna. There's a question from the room. Come over, Francesco.
Hi Anna, thank you for the presentation.
Thank you.
Do you connect also the information that comes from those data sets and so on some analysis concerning the effect of climate change in in the area. So one of the first. The second is you make a comparison. You refers to point weather station compared with grid analysis and so on. For daily management of those daily water management for agricultural purpose, you need to include all those data sets, or you can go directly through one of them because it is easy to be managed in the current daily activities.
Thank you for the questions. Are very useful to me to explain some things, some ongoing works actually about climate change and climate evaluation. Those data, the reanalysis data, should be used very carefully because of course, because the global observation system, because the reanalysis uses numerical modeling combined with observation. So if we replay the most advanced numerical models back in the past, we can assimilate very frequently the observation that come from the global observing system. However, if we look back in the past, the global observing system is changed in time. So maybe over a very long period, maybe more than 50 years, that are the minimum 30 years, the minimum span period to estimate climate change, eventually climate trends. Over this period, maybe the data set is not fully consistent. So maybe it should be used with care. However, we are trying to correct some errors or to find some errors to have some information about climate change from these data. About the second question, we are also working on that in a project, in a PRIM project. Of course, for the real-time estimation of volumes, or for the estimation of volumes, irrigation volumes, some days in advance for irrigation scheduling, maybe. I think that you are talking about irrigation scheduling, about estimation of irrigation in real time. Of course, you cannot use reanalysis data, but you have to implement the same numerical weather prediction models, but in forecast mode. So you have simply to use a forecast with lead time of 1, 2, 3, 5 days. Of course, these forecasts have more errors than reanalysis data. So this study is specifically focused in estimating reference evapotranspiration toward irrigation volumes in the past. In the past, of course, in the recent past. So to have a framework, a complete framework over a region about irrigation needs and about the investment to do, maybe.
Thank you, Anna. I have myself have a question and a comment. The comment would be, I come from a very different field, which is special planning, and I was amazed at how you were speaking about the 30 kilometers and 10 kilometers as high resolution, because for us planners, well, we would like ideally to have something like 5 meters or 1 meter or something like that. But apart from this comment, I mean, my question has more to do with potential applications of these kinds of data sets. And I'm especially interested if, I don't know if you have some thoughts of that, in understanding whether this kind of data, historical data, as you just said, can be used, for instance, in ecosystem service modeling. And the question I'm asking it is, I mean, other than agriculture, as in your case study. And the reason I'm asking it is because there are some models which try and predict, for instance, the contribution of urban greenery to the cooling effect. And one key variable on which I always found problems to find reliable data sources is exactly evapotranspiration. So, in general, apart from agriculture, my question is whether there's room for other useful use of this kind of data sets.
Thank you for the question, because it's important. Yes, your question is very important about resolution, special resolution of database. Of course, I understand that it could seem that 30 kilometers or 9 kilometers is not exactly a high resolution. However, when we some variables can be only predicted with this type of resolution, and think that if we have a weather monitoring network, we have just maybe one station, one weather station over, I don't know, 70, for instance, in Campania region, we have one weather station in 70 square kilometers. So at the end, if we have a measure in a point, and then we have to apply, as I said, some geostatistical techniques, at the end, the native resolution of the monitoring network for sure determines the errors in the estimations. So we cannot go with smaller size of resolution without committing errors. But for some other indexes, for instance, the leaf area index, the crop parameters, index of crops, we have multispectral images from satellite. And in this case, Sentinel-2 gives a resolution of about 20 meters. So according to the second part of the question, I think that there is a lot of room for using this data for other application in the hydrological sector. However, for when we estimate evapotranspiration temperatures, this is a very good database. The reanalysis database is a very good database. But for rainfall, for instance, it is very biased. So we cannot use, for instance, in some context like hydrological modeling, because there are a lot of errors. But you can see also in the numerical weather predictions for rain, it's very difficult to have robust forecasts. So for sure, I think that it can be used also in other contexts when temperatures and evapotranspiration is needed. Of course, the resolution is still 9 kilometers, or also you can especially interpolate, but at the end you cannot go very coarser.
Make the resolution better.
But you do not have any other way besides measurements. But you can adjust. If you have measurement, you can adjust the model, the data with measurements somehow.
Thank you so much also for the tips. Yeah.
Welcome.
We can now move on to, unless there's somebody from the presentation we were missing in the room, no? So we can go to the last presentation, which is in presence, and Francesco Scorza will talk about a journey between sky and sea, investigating tourism ecosystem in Madeira.
Okay. This is the final episode of the series of presentations regarding our application, our application of this methodological approach to investigate the destination areas in tourism analysis, and the final journey between sky and sea led us to go to Madeira, Madeira in Portugal. We passed through many destinations in Europe. Today we go to Madeira. Okay. The framework is similar, but we have a colleague that didn't attended the previous and people online also that didn't attend the previous episode. So the idea is that we need to tackle tourism as a territorial phenomenon. It's a changing in the analytical and representation model generally connected with tourism analysis, because the main interpretation of tourism regards some other disciplines, for instance, economic studies, social studies, studies that regard the exploitation of patrimony, culture, nature, and so on, regarding sustainability in terms of ecological pressure that tourism generates on specific habitats and so on. We want to stress the comprehensive view that generally planners need to include a specific topic like tourism as a driver of understanding the local trends, territorial trends and territorial dynamics. To do that, we worked on the concept of a sustainable tourism ecosystem, which is a multi-scale approach that starts from the identification of local destination areas, which main which are mainly connected with the system of supply. So supply tourism chains. It means it combines attractors, uh, services and reachabilities, which are physical points on a map that you can recognize, you can retrieve, you can organize in a database, and through some specific spatial function, you can organize those information in order to identify groups, functional groups of points that represent a destination. If you consider also the demand information, so the tourism flow, the tourism presence, correctly organized in a comparable spatial resolution, you are speaking about a tourism system, so supply and demand. And when you also include in this analysis the system of stakeholders that are engaged in the process of tourism management, tourism planning, tourism decision, you are speaking about a tourism ecosystem. Okay, so that's the conceptual model that we refer to. We are at this level, the destination area, so a combination of attractors, services, and reachability. Attractors are points of interest that represent the motivation to travel. I go in a place because there is an attractor that, for me, that represents my destination. The reason of travel. Services represent the structure of support facilities that makes tourism possible. Because if I go in a place, I need some support services, accommodation for sure, and restaurants. So are the basic services. The list of services could be very longer, but in this analysis we refer to on those two categories. And the third aspect is the reachability. If I want to go in a specific attraction, I should have the opportunity to go. So it means not only accessibility on transport infrastructure, but the opportunity to get that place even through alternative way of movement, parking, active mobility routes, and something that regards also the activity that tourists engage in his trip organization, for instance. Okay. A point pattern, so we are dealing with a point pattern analysis, and we developed those exercise with students in architecture. So we are in this context. Each group of students analyzed a destination area very far from their context. Probably they have not been never there before. So it's a desk approach that allow quite a good understanding of the tourism system in each destination area. So we go to Madeira, and first of all, they analyze some information about tourism flow. And Madeira, of course, is not a minor destination. Is a primary destination for tourism in Portugal. It is an island. It is quite far in the ocean from the coast, and it means that also the tourism organization in Madeira is mainly oriented to overnight staying. It means you go there, but you stay more than one day. No, so you have a accommodation system that will support your presence in the area. It is the island is of course specialized in outdoor activities connected with the exploitation of natural patrimony of the area, combining both sea activities and mountain activities, because the island has inland areas very interesting from the point of view of naturalistic, also geological sites and other aspects, with important flows, no? Especially concentrated during the seasons, so during summer. And so some preliminary consideration comes out from the analysis of statistical data, basic data about the tourism flow. After that, the student goes through this point pattern analysis. In this case, for instance, for the island of Madeira and the small island which is connected with Madeira, which is Porto Santo, they retrieved 2,600 points. It means that only using some web services, especially OpenStreetMap and Google API Places services, in a desk-based approach, so without any specific cost for retrieving those data, you have a detailed description of the area. After that, they use a simple spatial analysis technique, which is the cluster analysis, in order to identify some groups of points that, for proximity reason mainly, works together. No? And those clusters are quite representative of the place, because are centered on the main urban centers of the island, and allow you to understand that the coastal urban center is connected with the structure of services that is in between the inland area and the coastal area. From this analysis, some consideration come out. First of all, they concentrated on hiking trails, because the connection between inland area and the coastal area becomes a primary issue to be considered. The number of viewpoints is something that characterized the island, because the viewpoints are territorial markers that encourage tourism to go in a place in order to have a special landscape view of the sea or a mountain and the sea. No? It's something that is very characterizing Madeira, but also other islands in the Atlantic Ocean. Then they put the interest on the topic of accessibility to the natural capital. So the hiking trail is a way to connect coastal area and inland area, and is also a way to exploit the natural capital, but they also concentrate on the attribute of safety of hiking trails, and so the accessible for all principle that comes also from the new urban agenda becomes one of the drivers of this event. At the end, the main issues becomes the connecting coastal area within inland area. About the hiking threat analysis, they go in the details, and for each cluster, no, the colors represent clusters, they compare some hiking traits that are that comes from the official network of hiking trails resided in Madeira, and they classify for the length, for the slope, for some attributes also concerning the services and facilities that are included in the state. It's a nice analysis. On those histograms retrieve the number of attractor services and reachability points in each cluster. So you can see that there are some strong systems that are mainly infrastructured for tourism services, and some weakest area of the island where the project could improve the actual services availability there. So these are the general principles that they consider. That those principles comes from the new urban agenda. So we refers to a global reference framework in order to achieve sustainable urban design. It is extremely exercise, so it is quite interesting to let's keep it connected with the general methodological framework at global level, operating at local design level. Finally, their project comes out. They are quite free in finalizing the design, concerning the analytical part that we propose them. Is mainly based on the realization of a new routes. New routes connecting coastal with internal area are quite evident, some here is another issue, but are quite comparable. They didn't design the routes in terms of specific and the real design, but they seem to organize the route with some specific facilities that are connected with outdoor activities. For instance, the gate, the starting point of the route, the information and athletic services, camping areas, picnic areas, rest areas, and the point of arrival that should provide some additional services. Here, someone yesterday asked about how change the services infrastructure according to the project. Here you can see the differences, no? And you will see that the infrastructure mainly goes to improve the services in the weakest area, while in the stronger system they don't think to invest and to develop general conclusion is regards the fact that the methodology was applied quite easily, with all the limitations that you can imagine, but we get a territorial representation, quite effective, quite detailed, used in order to have a strategic design, to compare also a development approach to the analytical part, so we're quite closely circled, and we combined this transversal topic that it is tourism development with horizontal principles that come from the new urban agenda. So universal design in this case, accessibility for all, inclusion and sustainable development for local people. And our idea is that also those products that are not research but are experimentation, say something which is between learning, teaching, and research, are good to be discussed also with, with you, and that's why it is the seventh episode of the series. I think
Of course, I'm listening to.
Okay. You missed it, something. You have to
I did.
go to Netflix and. Okay, thank you for your attention.
Thank you. So then I can ask check whether there's questions.
Have you got any question from the online audience? Then relax.
So I will go into one question which wasn't raised earlier in the earlier episodes, which has to do with the function. I think Raquel had mentioned that the function can take different forms.
Yeah.
Yeah?
Yeah.
Depending on the local context. Yes. And
Also of the analytical effort that you want to put in the analysis. No?
yes. And in this specific case, can you show us by means of example what the function might look like, or based also on the other case studies that you had, just to get a glimpse of how much computation is required and how it can be implemented.
I think that this is the simplest and the simplest approach because it's a cluster analysis. So it's something that regards only distribution in the space of the points. Of course, you have to take care about some parameters and you have to achieve a result that is significant for describing the place and so on. So it is the purpose. The extreme computational effort, Simone worked a lot on that and passed through the development of a graph. So the points becomes a graph, and through after realizing the graph, you can use computational metrics that regards the graph analysis. And through the graph theories, the, the community of points could be identified through additional attributes. The first attribute is not only considered the Euclidean distance in the space of the points, but to include a measure of accessibility. So point by point, the arc between in the graph is weighted in terms of time connection.
On the street network, if you talk about driving by car or the federal access between the two points.
So, of course, and it is an additional attribute that brings you to more detailed interpretation. Additionally, each point could have other attributes. For instance, we say rating or a number of review or any or cost, medium cost for accommodation that are data that comes from the online retrieve of each information. For concerning attractors, specific data about this number of visitors, number of tickets, if you think a museum, something like that, and so on. So, and those attributes becomes important if you go in a spatial analysis of this graph, no? Where he applies some machine learning techniques in order to extract information about the complex system. And in order to achieve the identification of the destination area in the more functional perspective, because the closeness is an attribute, but to identify a system that supports Castel del Monte, yes, we were speaking about Castel, which has a strange configuration because Castel del Monte is quite isolated, no? The system of services is not very close to the castle, and it is in contradiction with the general principles that if you have an attractor in an historic center, you will find around that attractor the best hotel, the best restaurant, the best facilities because of localization rules. No, so in order to understand better how the system works locally according to the tourism function. We have
need to add some other attributes because in this way we want an analytical model that uh, identify this function and changing something, do a scenario analysis and say, okay, if I add another attractor, or if I add another services, if I improve the accommodation, how the model change. So
But that means that the first step is that understanding which function I should use, uh, then might change the results in terms of the identification of the clusters. And so I was wondering whether you also run some kind of robustness check or sensitivity check. So how does the configuration of the clusters before doing your
some
project,
changes. Okay.
yeah, how the clusters are robust and stable regardless of the function.
yes, we cannot compare the results of different functions. But inside the computation of the function, especially in the more advanced system, the check about the robustness, the statistical significance.
Because we iterate, we not identify just one configuration and say, okay, this is the one configuration. No, I just iterate, I change some parameters because it's community detection. It's a parametric, so we change the. It's like a random worker that work on the network. So we change the times that this worker go through the different services on a community, and so we just mean this different iteration. I say, okay, this is the mean of, for example, 100 iteration. So we know that this community maybe work together because on the system it work because we have to validate our model. But the only way to validate, as say, we need the supply of we need the demand of the tourism. Because for now we just modeling the supply, and as the taxonomy that Rachele proposed, we need to identify the system. We need to know how the people move on territory. So identify some destination area that maybe work together because the systems say, okay, this is accessible each other. They have a lot of services. They have some very attractive attractor. Okay, so maybe people move from one destination for another destination. So this system needs to work together to improve the system itself. But the only way to validate this is to have data on the tourist flow, and it's not so easy. We are waiting for for some data for just 2 years now, or 1 year and a half. Maybe at the end of the project we have this data, and uh, we are not sure that our model works because we can, by experience, we know it in some application in Basilicata or in Calabria, we can know this. But if we want to go to Madeira, for example, it's difficult to say, okay, it's work. But it's at least we try because it is another approach to analyze the.
And finally, the check could be statistical, but the keywords of the interpretability of the black box that comes from a very complex territorial analysis, I think is the key. If you discuss with people, they recognize that the system works in that way.
That's some sort of validation.
It's the real validation. That math becomes useful. It meets the needs of a local operator, local decision maker about that, and contributes to develop the additional territorial knowledge. No, because when you have to spend 20 million and you don't pick your bunny for bundle board, and so on, and you make just a list of infrastructures. I don't think that the local decision maker has the perception of how the system works and how the system what the system needs in order to improve. It works well in a sustainable way or not. So it is also a monitoring system that improves the capacity of the
I have a question. for you.
For me.
Yes.
Let's change the rules.
Due to my limited knowledge about some techniques, maybe applied in different fields, but very high level technique. You know, for example, I never made a jig work.
Yeah.
Great.
Geographical information is good.
I will speak. The main sort of lie on this model is that tourism is a local product that you must consume in the place where you are. It's not like other services that could be telematic, for example, or rely on other kind of stuff. It's site specific, and the distance between the distance between the attractors and all the elements that belong to the value chain is the main discriminante, is the main case of selection of a to have a cluster, no? So this reason is our definitional. I was wondering, what if we are going to take it in account. For example, we review the number of ratings in the definition, no, of the cluster, and with this kind of technique, how can you say that is the right way to consider the cluster?
No, I was not raising any doubts on how they identified it. I was wondering whether the selection of the function might lead to different results, which I guess is the case. I mean, there will be some areas which, regardless of which function we choose, they will still be there in the cluster. But other areas might kind of fluctuate from cluster to another, depending on how you choose
The function.
and that's where some kind of sensitivity checks come handy, or iterations, and also like permutation techniques, as Simone was suggesting. But I don't think that we can solve this problem because it's like an edge effect. Yeah, and the edge will bounce back and forth from one cluster to another. I think there's no solution. It's only like acknowledging that there's this issue, that you can somehow check what happens if, but you cannot definitely say, oh, this place belongs here.
And not
Yes.
that.
Yeah.
Absolutely. No, yeah.
And there are some overlapping because there is some techniques that make into account that are overlapping because
Yeah.
it's not strictly clustering. It's overlap the clustering because there is one function or this is one type of tourism and another type of tourism because we want to define different type of tourism. We know that services serve to a different attractor. Okay, and we're not implemented yet. We know that there is this technique, but we are working also to make the model flexible because the idea is if we have a model that works like in 10 minutes, in 15 minutes, we can go to with the policymaker and say, okay, you have 20 million. Let's try to change this one. View the new configuration. Did it work for you or no? We can.
In 10 minutes you give a result.
Yeah, in 10 minutes.
2 days
15
of
yeah.
analytical computation. Yeah, the result will be better. But
Yeah,
probably
Only
too
if
late
you
for the
have
technician.
Simone, otherwise it will be 2 months.
No, it's not. No, because we try to have a very general and flexible approach.
Yeah,
This is our aim at least.
but probably at the end of the story, when there is a case study, when there will be a case study well known, well analyzed, and so on, the comparison about the function is an argument in order to let people aware that if you choose low computational effort, less data, less attributes, you have results that it is weakest,
Yeah.
the best one, but
It's really simple, yeah. Because if it works, we know that we don't have so much data. We have a problem with data scarcity. So if a very simple approach works,
okay.
why not?
Yeah.
It's,
If you want to go deeper,
yeah.
let's go on. No,
Yeah. But at least this is research. We don't know if it works or not. But, and
Thank you so much,
thank you.
everybody. Sì, hanno dato una domanda
Okay. Dai, finita, no.
Thank you so much, Martina and Anna, for your great presentation. And we're going to close the session now, and we'll have a coffee break. And see you in some other venue. I don't know. Bye.
Thank you. Bye.
Bye.